Today we talk about CAD software for makers. In this video, we first talk about the criteria that are important for us when it comes to a CAD software, and then talk about some of the software solutions we are using and their advantages and challenges. At the end, we will talk about what software we actually use for 3D printing, woodworking, laser cutting, and other tasks. Let's look at the criteria that we will use in the second part to judge the different solutions. Is the software a 2D or a 3D system? The first and maybe most important difference between CAD systems is if you're looking for a 2D model that could serve as a template to transfer to your material, or that would enable you to create shapes for a laser cutter or vinyl plotter, so everything where you have no thickness but only 2 dimensions. If 2 dimensions are not enough, you're looking for a system that can model things in 3 dimensions, so you can plan a woodworking project or create a shape for 3D printing. Does the software support the design of single parts in a good way? If you work with a 3D program, some are better in designing a single part. For CNC work and 3D printing, you will most of the time be focused on an individual part and have less of a focus on the connection between a lot of individual pieces. Does the software support the design of multi-part assemblies in a good way? In woodworking, most of the time, you will work with projects that have a lot of parts. This table is a multi-part object that consists of 4 legs and a tabletop. Overall, it contains several objects that are positioned relative to one another. We will see that some CAD systems are better or worse in the assembly of several parts. Does the software offer parametric design? An important question is if your software is able to create a parametric design. If you design a table in a non-parametric software and decrease the size of the tabletop, you have to manually adjust the table legs. In a parametric software, the position of the legs will automatically be adjusted as they reference the edge of the table rather than an absolute length. Does the software support artistic sculpting? In the example so far, we looked at shapes that are square and based on precisely measured objects. You want to have a look at the different kind of software if you plan to get creative and work with organic sculpted shapes. Does it output CAM? After creating a model, we want to do something with it. If you design something for the CNC, you want to create G-code that the CNC can execute to cut out the shape you designed. This is called CAM. Some software solutions have a CAM integrated, others don't. Does it support drawings and cut lists? For traditional furniture, it is important to have a good drawing and ideally a cut list that helps you to cut everything to the right dimension. Is the software free? All the software I talk about in this video doesn't cost you any money. There is, however, an important difference. Some of the solutions are free to use as long as the vendor of the software think it's more beneficial to hook a lot of new users to its solution rather than getting money from those that are already using it. This could, however, change every day. Other solutions are open source software where you do not only get a CAD system but also the source code, so to say the assembly instructions for the software, and you will always be able to use it. Now let's get started and look at the software that we are using and solutions that we are using less or not at all. For 2D work, we create nearly all projects in the free and open source software Inkscape. It is similar to Illustrator, so you can draw simple shapes but also get very artistic and design organic shapes, such as the pattern for the living cell table design. Besides templates, Inkscape can also produce shapes for a laser cutter or a CNC machine, and it even includes a simple CAM solution that can create G-code. Inkscape is our go-to 5-star rated solution for everything in 2 dimensions. The only disadvantage of Inkscape is that it is not parametric and it is not easy to produce measured drawings. If measured 2D drawings and parametric design are important for you, you might want to look at LibreCAD. It's a great open source 2D CAD program. However, when a project requires a parametric 2D shape, you can create it also in a 3D CAD program. Therefore, we use LibreCAD very seldomly and excluded it from the list. The next software on our list is Blender. Blender is a super powerful 3D modeling and animation open source software. You can create entire short films in Blender, and we use Blender to edit our videos. Blender is a perfect solution if you want to sculpt a model or if you want to modify a file before 3D printing it. While it is excellent for creative modeling, Blender is not parametric. And while you can use it out of the box for traditional CAD work, it is a bit cumbersome. It also doesn't offer technical drawings, but what you can do is to import your model from another CAD software and create a photorealistic rendering in Blender. While there are a few CAM add-ons for Blender, none of them seems to be actively developed and maintained. For a long time, Sketchup was our go-to solution for 3D modeling. It is a great solution especially for complex assemblies with a lot of parts. Another great feature is that while the drawings are mediocre, with an add-on you can create a cut list that is very handy for woodworking projects. We stopped using SketchUp for a couple of reasons. First, the vendor of SketchUp, Trimble, offers the new version only on the web, which means that they can limit the access easily in contrast to the old version that would run forever on your local computer. Secondly, the Ruby scripts, such as the cut list add-on mentioned before, no longer work in the web version. Thirdly, SketchUp is not parametric, and the free version is missing some critical features such as Boolean operations that make it very hard to use for single shape 3D printing models and sculpting work. So for our use cases, SketchUp is inferior to Fusion 360 in all relevant dimensions. The same is, by the way, true for Onshape. Onshape doesn't allow commercial use of the models and automatically publishes them as public domain models. With a feature set similar to Fusion and a very restrictive license, it's not an option. Which brings us to the next solution on the list, Fusion 360. Fusion is perfect and comes with all the features you ever wanted. It is parametric, has an easy user interface, allows for sculpting, creates CAM path for your CNC, and create renderings as well as technical drawings. So why bother about any other solution? Well, it's this one sentence in the Fusion license terms. Its vendor can change the license at any point in time and afterwards can charge any amount of money. Now, you might argue that this is pure paranoia. Why would a respected company such as Autodesk offer a solution for free, build up a community, invest in the product just to discontinue it or charge money for it? The reason is pretty simple. They are driven by shareholder value. If a solution, such as 123D Catch, which used to be another free Autodesk solution, doesn't contribute to the company's profit targets, it will no longer be offered for free. If you feel uncomfortable with putting all your eggs in one basket, given that the rent for this basket might be a few $100 going forward, have a look at FreeCAD. As Blender and Inkscape, FreeCAD is open source software. That means you can download and modify the source code of the software. Even if the website closes down, you will always be able to use the software and adopt it to your needs. FreeCAD is still under heavy development, but it comes with a full parametric design system and is able to create G-code as well as technical drawings. It is not that great for multi-part assemblies, but looking at the prototype for a new assembly system, that could change quickly. It might be more difficult to get used to the software, but for us the benefit of using an open source software easily outweighs the more difficult learning curve. The last tool on the list is a bit of a niche solution. With Openscad, you create your model with a simple programming language. The software is too complicated for multi-part assemblies, doesn't allow sculpting, and it's difficult to create a technical drawing. We mainly use it to create models that need complex parameters, like these Voronoi vent covers, and to create parametric models for Thingiverse. Which brings us to the last section of this video. When do we use which software? When we draw something, we usually use Inkscape. It's easy to draw, for example, the shape of this Klingon push stick design. We also use Inkscape to send designs directly to the vinyl cutter. For the laser cutter, we create SVG files as this tool holder in Inkscape and send the SVG files with K40 Whisperer to the laser. When a lot of parts have to fit on a single sheet, we use the open source software deepnest.io to arrange the parts in a space-saving way. When the measurements for a 2D design are complex, as for this coin sorter, we create the drawings in FreeCAD and export the DXF to K40 Whisperer. When a 3D printed design such as this router jig needs to be configured with a lot of parameters, we create it in Openscad to make it easier for people to configure their own version on Thingiverse. When a 3D printing project doesn't need to be configured online, we usually use FreeCAD. There honestly wasn't a project on our list that FreeCAD would not be able to handle when it comes to the design of 3D prints. For creating and modifying STLs from Thingiverse or other sources, Blender is the most convenient tool. It is easy to cut away part of the model, merge several models together, or modify the mesh. For the CNC, we also moved from Fusion 360 to FreeCAD. We are no experts on the CNC, and while using Fusion, never managed to wrap our heads around the more complex options of adaptive paths and all the other advanced CAM features. A real expert on the CNC most likely doesn't want to use the FreeCAD CAM module due to the lack of features. For us, this lack of features is actually an advantage, as it means we have less possibilities to mess things up. For woodworking and metalworking projects, choosing the right solution is quite difficult. We have some of our old models still in Sketchup, and it's cumbersome to work with a non-parametric system once you got the experience of working parametric. We did some models in Fusion and are missing the possibility to create a cut list. FreeCAD has some possibilities to create a bill of material, which is a very good starting point to create a cut list in another software such as Cut Micro. Arranging several parts in FreeCAD is either simple or parametric. Moving parts in FreeCAD is easy, but these connections are not parametric. There is a possibility for parametric assemblies, but it's quite complicated as each part has to be saved in an individual file, which is especially for woodworking projects where most parts are simple boards not practical. The great thing about open source software is that everyone can improve the software. So on GitHub, you can find a modified version of FreeCAD that actually offers a quite powerful parametric assembly. As soon as this feature is stable, FreeCAD should be able to provide everything you need to model furniture. Till then, we will have to work with assembly options rather on the level of SketchUp than what Fusion 360 is offering. This was a quick overview of the CAD software we are using. It's a very subjective listing, and most likely your personal preferences are different. Are we missing something? What software do you use? Let us know in the comments. Also have a look at our other videos, don't forget to subscribe and follow us on Instagram for a look at future projects.